Hello, thank you for joining us today for our talk. The topic of our talk is a state-dependent activity of V1 SST interneurons and their association to encoding of visual stimuli experience. By experience here, we mean whether or not the mouse has seen any stimulus before or not, and therefore it's novel or familiar. We know interneurons in the mouse primary visual cortex, or V1, are responsible for mainly gain modulation and tuning to different features. What we are interested in are two subtypes of GABAergic interneurons in V1, which are somatostatin expressing interneurons, or SST cells, and vasoactive intestinal peptide expressing interneurons, which are VIP cells. What do we know about VIP and SST cells? We already know that they are found in most parts of the cortex, but they're usually in prefrontal and mouse primary visual cortex. They are usually seen and studied in layer 2 to 3 of the cortical slide, and their VIP cells are responsible for front to back motion, which is congruent with self-motion. And usually they're better in low contrast. And the VIP and SST cells together, they have some kind of complementary contrast tuning. But aside from these, we want to know, do they also code experience, which means novelty or familiarity? The data set that we used is a 2-photon calcium imaging data set from the Allen Institute. And the task is a change detection task performed by the mice. What we are interested in is whether or not the SST and VIP cells in the V1 of the mouse are responding to the novel or familiar stimuli shown to the mouse. Here we see the task design and the task flow of the behavior performance of the mouse. We see rapid succession and repetition of showing and displaying the stimuli to the mouse, and we see the collection of the reward here shown in the purple triangles, and the collection and means licking of the mouse here shown in the green lines. It's good to note that a small percentage of the stimuli are randomly omitted to account for different analyses and to account for reward expectation error, which we will see in the coming slide. We use different machine learning methods like logistic regression, linear discriminant analysis, random forest, and ensemble learning, and compared them for computing our accurograms. Accurograms is our novel way of computing the accuracy of a machine learning over a small period of the trial times. So we start computing our accuracy, for example, start from before the trial onset. We start computing and convolve our accuracy and analysis window over all of the range of the trial times. You will see the example in the coming slide. The results show that for the raw activity pattern of VIP and SST cells, well, there is some stimulus-dependent activity. But in the case of the omitted trials, VIP cells show a wrapping activity, but the SST cells get inhibited and doesn't show any activity when the stimuli is omitted from the screen. For the sake of accuracy of our different cell types, SST cells show a constant trend in activity and doesn't show to be stimulus dependent on the accuracy scales of our machine learnings. But the VIP cells are very stimulus dependent. And lastly, for the comparison of our different classifiers with respect to our 8-fold cross-validation that we used, we didn't see much variance between the models, and the difference was below 1% in variation. Here we see one example of an accuragram. We see that the SST cells show about 74% accuracy, which is better than the VIP cells, but it's not changing over the trial times. and the stimulus onset here is around 0. So we see no change in terms of accuracy when the stimulus is shown. So we might conclude that the information in the SST cells is already present in all the trial. But the VIP cells shows greater accuracy when the stimulus is being shown, and when the trial is going to the gray screen after the stimulus, the accuracy drops. Here, we see the same accuragram, but in this case, for the omitted trials. We see for the omitted trials, the accuracy for the VIP cells around time 0 gets diminished significantly, but for the SST cells, we see no change. And that's interesting. So we might conclude that SST cells carry information regarding the experience of these stimuli throughout the session, even in the gray screen intervals. And the pattern of these SST cells might differ in 2 states of exposure to novel versus familiar stimuli, and it might be state dependent. So an SST cells with the pattern coding might include, for example, the novelty in one case and the familiarity in the other case. We might speculate that why this is the case and why we see a novelty and familiarity pattern in the V1 of the cortex. There might be because of some circuit connections from the low order regions and the connections from the hippocampus, for example, or the thalamus. Further studies will be needed for this. This is the data set that we used from the Allen Institute, and this is the article that we used the figures from. This is our team, which have been doing an amazing job in the task. I am Hadi. This is Mortaza, Ali, Mustafa, and Mehdi. And we'd like to thank you and the Neuromatch Academy for this great experience and opportunity. I'm happy to answer any questions that you might have on the Discord channel, or you could just email me with my contact below. Thank you. Have a good day.